All right, lesson 25 is on the geometric interpretation of the solutions of a linear system. So again, we are working with systems in this topic D here. And don't stress about this whole geometric interpretation. Basically, let's solve this by graphing, okay? So we're dealing with linear equations here. So let's try to remember the different ways we can graph. So one of the ways that we learned to graph our original way is by making an input-output table. Input-output table. All right, so that's when we started. We'd make like a t-chart, and you'd pick the values of x, and you keep plugging them in to get the values of y, or vice versa. And then the second way we learned to graph a linear equation was slope-intercept form. Y equals m times x plus b. B is our y-intercept, m is our slope. So if it's in slope-intercept form, we can plot our y-intercept and then apply our slope. And then the third way that comes in handy sometimes when we're dealing with things in standard form is using intercepts. Okay, using intercepts. And that's, remember, we put 0 in for x, and then we put 0 in for y, and find out where it hits our x and y axes. All of these will work with any of them, but sometimes using one method or the other is a little bit easier. Okay, so we've got our ways to graph. Now let's talk about a system. Okay, remember, a system is just two or more equations that are dealing with the same thing at the same time. Okay, so here's our system. We have 2y plus x equals 12, and y equals 5x minus 6x minus 2. So you're going to go through the process twice using this to graph it. So this first one here, 2y plus x equals 12. We can make an input-output table. We could put it in slope-intercept form and solve, or we can use intercepts. When something, and this isn't in standard form because the x would have to come first, but when something is written like this, I'm going to look at the coefficients. Well, I'm going to write it correctly first. And then I'm going to look at the coefficients, putting a 1 in there. And if both of these coefficients can go into my C over here evenly, I'm going to use intercepts because that means I'm getting integer answers. So this is a good reminder of how we use intercepts. Start by putting 0 in for x. Okay, so right here for x, I'm going to plug in 0. And I'm going to go 2 times y plus 1 times 0, or plus 0, equals 12. Well, that 0 doesn't do anything, so I'm left with 2y equals 12. Then I divide both sides by 2, and I get y equals 6. So we can think of this as the ordered pair 0, 6, or you can think of it as the y-axis. I have to put a dot at 6. All right, then we do the same thing here, but we're going to put 0 now in for y. So now I'm going to plug it right here, and I'm going to go 2 times 0 plus x equals 12. Well, 2 times 0 is just 0. If we add 0 on anything, it doesn't change. So I just get x equals 12. So I can think of this as the ordered pair 12, 0, because remember, x coordinate, y coordinate, or I can know that when I plug 0 in for y, I go to my x-axis at 12, and I know it's hard to read, and I can put a dot. Then we need to draw a line through these, because this line, remember, is representing all the possible pairings of x and y answers, x and y values that make that a true statement. Okay, and really try to go like through the grid line. Sorry, I don't know why that's popping up like that. And definitely use a straight edge, okay? Okay, sorry about that. All right, so now the second equation is right here. And I'm going to write it up here. Y equals 5, 6, x. Instead of saying minus 2, I'm going to change it to addition. Keep, change, change. Keep the 5, 6x, change minus to a plus, change 2 to a negative 2. Okay? So remember, this is in slope-intercept form. Whatever is being added on is our y-intercept. So I'm going to go to my y-axis at negative 2 and put a dot. And then this is our slope. The coefficient of x is our slope, which remember is rise over run. So since they're positive 5, I'm going to rise 5. 1, 2, 3, 4, 5. And it's a positive 6. I'm going to go to the right 6. 1, 2, 3, 4, 5, 6. You could do it again if you wanted. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5, 6. More than one point usually helps you draw the line. Okay, then draw a nice long line through them. Really focusing on going through the grid lines. This one needs to be a little higher because that wasn't exactly at the top. Okay, so now we have just graphed, sorry, that wasn't exactly at the top there. We have just graphed our first system. Well, not really the first. We've been doing it in our power standards. So what does the solution to a system mean? Okay, it says name the ordered pair where the graphs of the two linear equations intersect. Okay, so the blue line in my case represents all the pairings of x and y values that make this true. The pink line represents all the pairings of x and y values that make this true. At what point, at what x value and at what y value does it make them both true? And that occurs right here, okay? Our x value is 6, and our y value is 3. So our ordered pair is 6, 3. Keeping in mind, remember, x and our y. So now we want to verify that that's true, that they both are, that the ordered pair 6, 3 does make them true. So we just plug them in. Verify, we're just plugging it in. So for my first one here is 2 times my y value is 3, plus my x value of 6. Does that equal 12? Well, 2 times 3 is 6. Is 6 plus 6 equal to 12? Checks. Try for the other one. Okay, does y, so does 3 equal 5, 6 times my x value, which is 6, so I'm going to write it as 6 over 1, minus 2. Well, does 3 equal, those 6's cancel out to be 1s, and I have 5 over 1, which is just 5 minus 2. Does 3 equal 5 minus 2? Yes. So you see how that ordered pair makes both of them true statements. Could the point 4, 4 be a solution to the system of linear equations? Well, let's look at our graph first of all, okay? The point 4, 4, 4, 4 occurs right here. So it is on the line, the blue line, right? The first one. So if I took that first equation here, it's right here, and I went and plugged these in, 2 times y, which is 4 in this case, plus 4, does that equal 12? Well, 2 times 4 is 8. 8 plus 4 does equal 12. That checks, okay? It is a solution to that equation. The problem is it's not a solution to this one. X, y. 4, does that equal, I'm plugging it into this equation right here, 5 times 6, no, I'm sorry, 5, 6 times 4 over 1 minus 2. So I just plug these values in here. And I'm not going to go through all of this. This ends up being 20 over 6 minus 2. Whatever that works out to be, it doesn't equal 4, okay? So since that point isn't on both lines, it's not a solution. Okay, it's a solution to one of them. Great. Okay, when we're saying is this, you know, is it the solution to the system? We're not saying is it the solution to this equation or this equation. We're saying is it the solution to both equations. The 0.63 right here, that is. The 0.44 though is not.